Hello. This video is about L'Hopital's rule, which is a very particular method of evaluating certain very particular kinds of limits. L'Hopital's rule actually appeared in the first textbook on differential calculus that was published more than 300 years ago. L'Hopital, in fact, wasn't the first person to write down this rule. It probably goes back at least to the Bernoulli brothers. The limits that we work with are called indeterminate forms, and there are several of these, and it's a fairly general term. And what I hope is that when we come to the summary at the end of this video, we'll be able to say exactly what we mean by an indeterminate form. Essentially, these forms are limits that are built up from elements that pull irresistibly in radically different directions. And so, for example, we'll have a 0 over 0 indeterminate form. The numerator would like the limit to go to 0. The denominator would like the limit to go to infinity. And we have to have a method that tells us who's going to win that particular battle. So here are some examples of indeterminate forms. Here I have the limit as x goes to 1 of root x minus 1 over x squared minus 1. As x goes to 1, root x goes to 1, and so root x minus 1 goes to 0, and similarly the denominator goes to 0. So in this limit is a 0 over 0 form, and so we'll need a technique that lets us figure out which one of these two sides of this battle actually win. For the limit as x goes to pi over 4 of sine x minus cos x over x minus pi over 4, we have that the denominator goes to 0 because x is going to pi over 4. But in the numerator, what we know is that sine x has the same value at pi over 4 as cos x. They each have the value root 2 over 2. And so since each of them has the value a half root 2, when you subtract those, you get 0. So this is a 0 over 0 form, and we'll need a method that lets us calculate that limit if we want to know that limit. Okay, so what does L'Hopital's rule say? It says that if the limit of some function f of x as x goes to a and the limit of some function g as x approaches a is in each case 0, and the limit as x approaches a of f prime over g prime, so those are the derivatives, derivative of f over derivative of g, if that limit actually has a value, so we can evaluate it, it's not an indeterminate form, it has a value, then the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime over g prime. So if we have an indeterminate form, we can replace the f over g with f prime over g prime and try to take that limit. And if we can take that limit, the value we get will be the same value for the original limit. And that's all there is in L'Hopital's rule. The key is to figure out when you can actually apply L'Hopital's rule. And the only trap that students tend to fall into is that they like to apply L'Hopital's rule to every limit that they run into. And if it's not an indeterminate form, L'Hopital's rule will give you an incorrect result. So it works for infinity over infinity forms as well as 0 over 0. So I've given an example, log x over e to the x. Log x goes to infinity and e to the x goes to infinity as x goes to infinity, so that's an infinity over infinity form. It works if f prime over g prime has a limit which is plus infinity or minus infinity. And it works if x is allowed to go to plus infinity or to minus infinity. So it works in all those cases. The key is that the object that we're taking the limit of should be a 0 over 0 form or an infinity over infinity form.